To do this problem, we need to get this concept straight. So I wrote this short code to illustrate it. The question is this: where on this x-axis should I go so that this number is minimum? So now if I go here, obviously it would lengthen it and is over 4. If I go here is 3.7, but somewhere between 3.7 and 4, there is a smaller number. Now you see 6 points. I will read the second digit because it will be 3.6 all the way. So it's 8, 7, going down, 6, 5, 4, 3, 2, 2, 1. I'm reading this third digit here, okay? 1, 0. Can I go lower? No, it's going back up. So 3.60 is as low as I could go, not below. So it's going back up again. Maybe this is the lowest number. Around this is the lowest number. You get the idea, right? It goes down. Around here is the lowest. Okay, let's read the fourth number. It's 5 here now, okay? 6, 5, 6. So somewhere here is the lowest number. So how do you find it is the question. The answer is, have you thought about it? Pause and think about it. How to find the lowest number. Okay, did you think about it? It's just mirror this here. Make it go here. This is how the mirror reflection happens. It appears to be on the other side of the mirror, right? Object. That's the shortest path. So what you do is you send this point to the other side and let this one just cross freely. So now let me send to the other side. It's -2 now. So it went to the other side. This is what I get. So whatever that makes, the point that makes this line go straight is the shortest. So no wonder it was around there. Now that we got that concept straight, let's do this problem here. So we are going to assign a coordinate, whether depending on the parity, whether the number is even or odd. So we're going to define a function p of n, except we cannot define straightforward. We have to use a condition here. So if the number is even, then do this. So what do? N squared is going to be. Okay, if that's not the case, then what's the coordinate here? It is n squared, comma, n squared minus 1. Okay, so that's why I illustrated this earlier with the two different heights. Because if the heights were the same, like that, then the optimal point is a midpoint, obviously. Right? But it wasn't. See, that's why they threw this in. So it was not the case. It was like this here. So we had to somehow painstakingly find a point that is optimal for that. Okay, so that's the point we got here. And then what are we doing here? We have to have an x that lies in the x-axis. That's this point that I illustrated. And not only that, it has to be sandwiched. So it has to be an odd point and x-axis, even point x-axis, odd point x-axis. In other words, it will just have irregular patterns like this, repeated over and over. Okay. So how do we do this here? It's here. Shall we visualize this here? So they want to go from 1 through 99. So let's do it here. So I'm going to make a table of P of n, where n goes from 1 through 99. Okay, so there's going to be these numbers. And shall we plot them to see what they are, where they are? So they go like this here. It's n squared, so it's not evenly spaced. It gets more sparse as it goes, but this itself is misleading because in between each point here, it has to go down and hit x-axis somewhere in between. See, it just lies on x-axis. So conceivably, it could go like that and then come back to the next guy, right? And then next one could go here and then go to the next one, and so on. So it's extremely vague, but it's not so vague if you use the concept I just showed you. So as it bounces up and down here, if you want to minimize the distance, See, it's the least possible length. So therefore, forget the x-axis. Make this guy go to the other side. Where did we start? We started with the odd one. So make the even one go down. Doesn't matter, actually. So I will make the even one go down. So when I do this here, the graph becomes this. And now I'm connecting them. So if I connect them, it becomes like that. And you see, this is going through the x-axis as they asked. And then this is the minimum distance that we are looking for. Okay, excellent. So how long is it? How are we going to measure this? Let's measure it. So this gave me all the points, right? So these are the points. I'm going to make a line out of it. So this is the line. And then I need to know how long this is. So I got to find arc length. See, this would find the length even if it's not a straight line. Even if it's curve or parabola, it will find the length for you. So when I do this here, that's the length I got, and that's the answer.